our long-term goal is certainly to slow and prevent tauopathies, which the most common tauopathy is Alzheimer's disease. But in the meantime, I think we can learn more about the biology and the molecular underpinnings of that disease to help give others additional targets and information about what to go after in tauopathies like Alzheimer's disease. So we identified a molecular chaperone that promotes tau aggregation. So this molecular chaperone is increased and associated with tau pathology in the brains of Alzheimer's disease patients. And we found when we overexpressed it in a mouse brain that had tau pathology, it increased the speed that the tau accumulated and increased the neurotoxicity associated with that. And so what we're working on now is small molecule disruptors of this protein AHA1 and its other partner protein HSP90, which we've seen in vitro can slow the accumulation of tau. And so we're really trying to take that forward to see if that can work also in vivo.
And what we're doing is we're taking a unique approach. We've identified a protein that is contributing to the accumulation of misfolded proteins called neurofibrillary tangles, or based on hyperphosphorylation and tau. We think of Alzheimer's disease as a protein misfolding disease, and so what we want to do is we want to find a way to force the machinery to go back in there and stop this misfolding process, or to take the misfolded proteins and deaggregate them. And so we're developing small molecules that modulate these proteins called chaperones. And chaperones are proteins that they're responsible for keeping other proteins conformationally mature. Just like a chaperone plays a role at a high school dance to make sure the students are mature, that's the role of the chaperones themselves. So we're developing small molecules that perturb this interaction to prevent further accumulation of misfolded proteins. The home run scenario is that we develop a drug. We have a really good compound. Right now we're trying to find a better way to get across the blood-brain barrier. It's just a very protective sheath, really, that keeps toxic chemicals out. And your body oftentimes looks at drugs as a toxic chemical as well, wants to keep it out. So we're trying to find ways to make this drug more penetrable through blood-brain barrier in hopes that we can make it more useful. And so Peekable ideally could take this as an oral drug in the future.
So the Harrington Discovery Institute recently funded us and has really been a great partner in helping us kind of refocus our project and make sure that this year of funding we're getting the most out of our target validation and our drug discovery efforts, so that way we can secure additional funding in the future. In addition to the funding for the research, having partners that are advising us on what routes to go, how to kind of troubleshoot certain aspects, how to add aspects to our projects we weren't thinking of before has really enhanced this project quite a bit and has helped us refocus in getting kind of the most bang for our buck this year and making sure we're driving it forward.